Here's my results from this experiment with the cart being pulled across the table. So changing the force and seeing what happened to the acceleration, it looks very linear. So hopefully your graph looked the same. Because it's linear, I'm going to put a linear fit on, a line of best fit. I don't need to do a test plot or anything. And high correlation, that's good. It means the dots are very close to the line. I've got a slope here, which I'm going to remember, 2.1, and then a whole bunch of units. I might leave them out for now because it's a bit confusing. We'll come back to them later. The slope of 2.1. Okay, so I've got some notes here for the discussion of this. So copy this into your lab book. You can pause when you need to copy them in. So we found a linear relationship between net force and acceleration. That's what that was meant to be across the crosses there. But linear relationship is straight line. Okay, another way of saying that is that the acceleration of an object is directly proportional to the net force. This means if I double one, I double the other. If I double the net force on an object, I'm going to double its acceleration. If I half the net force on the object, I'm going to half its acceleration. Another way of saying that mathematically is we found y equals mx plus c. It basically went through zero, so we can get rid of that. The x-axis was the force, the y-axis was the acceleration, m was our gradient. What did we say that was? It was something like 2.1 times f. Now, in the introduction to it, we actually had the mass of the object was equal to 0.47 kg. And there is a relationship between this number, this mass, and this gradient I got. So if I had a different mass, I would have got a different gradient in my experiment. And it turns out that the relationship is between this gradient is the gradient is equal to 1 over mass. So let's just check that. If I do 1 over 0.47, I get 1 divided by 0.47, I get 2.1. And that's what I've got here. So I can actually write my experimental result as 1 divided by mass times this. And another way of writing it is, there we go. Acceleration is force divided by mass. Okay, so make sure you get those notes down. And I will have another slide in the next video just explaining that a bit further.